Yahoo YouTube, how are you? Here is my finished typewriter and I just managed to write Yahoo YouTube, so perfect. Yahoo, whatever that word is, ignored. Anyway, that's not everything this one can do. You have a cursor which you can use to move around. And that one, and there you got backspace. No, backspace, that's delete. And you have backspace. So that's very convenient. Oops. Yeah. Okay. So this is my typewriter. It has the functionality of typing letters. Currently these are supported. I'm using weird shortcuts for the representation of the letters. Deal with it. And I have a bunch of controls, which is one CLR for clear. Removes everything and resets the cursor to first position. I have backspace and delete and left and right. So that's all the functionality a typewriter should have. And clear works. So I just showcase everything this one can do. And it's infinitely expandable. There's like no real border for that. And yeah, I think there's nothing more to answer except how does this work? And for that, I should maybe take a longer breath to explain that. First of all, the keyboard. I already made a quick explanation in another video how this works. Basically, every one of these has a value. All these values are added together because of the green wire connects them all. And if you destroy one, that value is missing from the total amount. So this little boy here stores the current amount, the total of all of these, and then this whatever got subtracted will be inverted, so in the end you get the value of each of these destroyed ones as a pulse on the red wire. Watch my video for that. This is just a simple monostable, and yeah, so we don't care what this actually does. We care for the red signal, which transfers the wire all the way over here to this. So as everyone can see, we got the pointer blink mechanism, we got here the pointer value where it currently is, here's the shifter. Okay, no, I'm not gonna explain this madness. It's totally not understandable. I just compressed this earlier, so I'm not gonna explain this in this way. We got something else. I got this one here, which is basically the same circuit, just a little bit exploded, so that it's more easy to explain what this control unit actually does. First of all, it just has this output here, and this one here. This red wire over here is just for the blinking cursor. It's just a wire which goes to every unit, and if the I value has the correct number, this one will be on. So there's not much effect to that. Just ignore that for now. For information, there's also the cursor blink machine that can be turned off or turned on. So if you prefer to not have a machine running amok on your world, you can just turn it off. This is just like a memory storage which counts up from 0 to 80 and then resets itself to 0. And this one subtracts 40 so that the 80 is cut in half, and whenever that value is bigger than 0, the pointer of the cursor will be transferred onto this wire, and so the cursor blinks. Quite easy. You can ignore this part for now. So this one is settled. Back to this pole. This pole has the red and the green signal, and they have two different functionalities. The red one in general is in charge of shifting everything in this display up or down for the cursor position. So I can say shift everything which is above the cursor down, or shift everything which is above the cursor up. That is the two modis which I have in each of these digits. And obviously I need to transfer the cursor amount to this red wire, and that is currently nothing. But that's the two functions which the CU can output onto the display. The other one is the green wire, which is in charge of setting a value. So I can select with the eye again a certain cell, and then that cell will be set. So whatever the input count is will be stored into the cell, which is this one, and then it will store it in the digit forever, if not shifted out. The other one over here is basically a reset or delete. In the same tick as you write to this, it also deletes it, but if you build a memory cell in Factorio already, you know that. I hope. Okay, so that's the outputs, and that is the pointer to the cursor. What is the rest? For that, let's start with the input signal. We got these two combinators which split the input signal. The first one checks if the input signal is below 1000. That means it's a letter and it needs to be saved onto the display. And the other one checks if it's 1000 or more, and that means it's a control letter. I have 5 control letters, and that is delete or clear, backspace, delete, left and right, and all of them are over 1000 with each value. For starters, let's go over the part which draws the letter onto the display. I am not sure, you should maybe watch a video about how such displays work effectively, but you got something in summary, you got something like a dictionary, which is this, and each of these pixels has one of these items as representative, and then it just checks if the item is set or not. So if I type something like an A, you can see that whatever just went wrong, you can see that it stores a bunch of items in the pixel, and that is how the display comes alive. So this is doing some voodoo magic, but in the end, after this one, you get the amount of signals or the amount of items for each pixel as one pulse, because currently I have space on the first character. That means there's no output here, but technically it outputs constantly. So if you put something else in the first position than space, it will cause this to output always. That means you need another decider combinator to check if the value from the library should be printed onto the display. That is done by simply having decider combinator which checks if anything is above 0. That applies to the input signal, and then it sends a pulse P. That is just rippled through these 3 combinators to delay the signal 3 ticks. And if P arrived at this point, the data from the library also arrived here, and it will be forwarded onto the display. Now we only need to add the eye cursor to it, which will also be applied to this one, and then each display knows if it's the one which should take all the inputs and save the inputs or overwrite itself. So that is basically everything for writing, at least for the most in a unit logic of it. But there's this special fellow. It has another output wire which goes into this section and to this combinator, and as you can see, that one is directly connected with the cursor location. What this does, it basically outputs 1, means the cursor will be moved 1 to the right side. You can also achieve that by pressing the right key, and that will also trigger this combinator which outputs 1. And the other way to do this is to press the left key, and the left key will obviously output a -1, which is the opposite direction of right. And yeah, we got another one of these here, and that is Backspace. I have this combinator 2 times in this version. It's once over here and once over here. So 2 times. It's just the same one. Just I didn't want to put a wire all over the place, so it's just a the same thing for you to more easily understand it. So whenever you use Backspace, it will move the cursor 1 left. Okay. Which part should I explain next? I think I'll do the pointer. So we have done drawing a letter, we have done cursor right and left. The next one is the cursor, or the pointer to the cursor location. This is a basic arithmetic combinator, a basic memory cell, which just stores whatever the input is. And that will be sent to the blinking cursor. It will be sent to, I should maybe explain this. After that, it will be sent to the shift when you type a letter. It will be sent to each letter when you write an actual letter, and this small unit, or in this one over here, which is another whatever. This one here just inverts the number which is currently in here, and will then, if C is set, let that number go through and delete this one, the combinator, with an offset of 1. What this does is whenever you press clear on the keyboard, you want the pointer to be resetted. So this red line over here will listen to the clear command. This is the catcher for the clear key. It will just output 1 C. The C will be transferred onto the display rows and will just cause any of the displays to trigger. Because C is like the first one, it will just disable all of them, 1, 2, 3, and all the other digits. We'll get back to that later when I explain the digits. Okay, so this is just a delete part. It reads from the pole, it's not sending to there, so that's the small difference. I could have connected it directly to this because that's the same effect, but that's not really required. So the cursor is just real easy, there's nothing special to it. Then we got this fellow. I didn't have this right before I made the YouTube video, and I was like, okay, cool, I'm gonna press Backspace. No, it was delete. Anything, it doesn't matter, because I was in the middle of a word and I typed a letter, and the letter overwrote the next letter. That is when you press, I think it's paste on your keyboard or something. I don't know the name in international keyboards. But that's not the mode we want. If we are within a letter and we within a word and we press a letter, we want that this actually is not doing what you just saw here, but we want that this will, I just showed over here. Let's type whatever I just typed. Okay, I typed this one. So we got some word, and now I'm gonna put a letter in. Then as you can see, everything above the cursor shifts up and then it places the B or something like that. But that was not the case because I forgot this little fellow over here, which just does the following. It checks if there's an input pulse, or if you are typing something, then it takes additional, it multiplies that by the I, and then it sends out a U onto the shift bus, which causes to shift up. That is what the U stands for. So this shifts up the whole number before you type a letter. So if you're typing and are not in the last position, the stuff which is behind the cursor will be shifted up, so you got space to put your letter down. Quite easy, but easy to forget. Anyway, the current version has it. I will update and I will upload the blueprint later into the Factorio forum and post a link onto the video of this. I managed to fail to deconstruct the keyboard again. I think I haven't mentioned it again, but there's something called push button mod, which is way better than this keyboard. But I only know this way of input, easy input. I don't know any other input. And you want to have such a neat layout for your keyboard. If you don't have this, it's like really a pain to put anything there. Okay, we had almost everything of the control unit done, but the top part. This one was the clear. Then we got these fellows, which we don't know yet, and this one. This is clear, this is backspace. Because backspace also gets triggered down here and shifts to the left side. What is backspace doing? It outputs a tick. That tick is just delayed by 3 ticks, because if this one below here triggers, we need to move the cursor 1 to the right side, and then we need to shift everything above the cursor down. Means whatever was the lowest position or whatever was at the cursor position will be removed, because we shift the one from the upper unit on top of that. So we got this delay here, and this is actually, this green wire is delete everything above cursor, which is the same functionality as the delete key, which does the same, it just outputs 1 tick here. So this takes outputs T, and does not output T. It listens for the tick to happen, and then it outputs the input count in D. And the input count is just I from the cursor position transferred into D. So that is basically what I did here and a little bit different. It's just the same thing. Here we just use up, and here it's down, and down is just sent onto the display, and then everything gets shifted down. So that is the whole control unit. Questions? Skip back, listen to my voice again, or write into the YouTube comments, or use the Factorio forum for questions. I will answer, but in the Factorio forums I won't get an email, so that may be delayed. So much to the control unit. The next part which I'm gonna explain is how the actual digit units are working, because this is again a mess, and it's not really easy to understand it, but once we explode this, it should be more easy to understand what that is actually doing. For that, I just go back to the old version of the display, which I haven't compressed yet. And as you can see, there's a pattern, and it might be easy to understand the pattern. This basically takes all of these combinators which are in this section and puts them into one small whatever part above that. This version has no cursor, and that is why I have a color combinator here. You can just ignore that. Okay, you see the green and the red wire, red for controlling, green for writing. So there are 2 combinators here on the green and on the red wire. Both of them have 4, which is the number of this digit, and both of them can optionally output S. S goes to the memory cell, and the memory cell, whenever the S is not 0, will be resetted. So the red wire and the green wire can reset whatever is the content of this current cell. As you can see, the data cell is additionally connected to a lot of combinators, basically to this one, these two, and that one, and these 2. That is almost everything here. Let's first start with the green wire. The green wire, as I said, is for adding or overwriting certain cells with a number. This one checks if the value is 4 and then outputs everything, whatever the content was, onto the green and the red wire. The green wire is just delayed by 1 and then output it onto the memory cell. So that is for setting the value. However, this part here removes the I. I said before I had the I sent with it to address each of these combinators, and this one eliminates it. It is, if I am correct, not required to do this step, but it's more aesthetic. I don't like it if there's a stored I or something. As you can see, there's also a stored P, which is like, why do I need this here? Well, I don't. And it's even worse if you have something like U and D stored in here, because U and D store control the combinators over here which do the shifting. So we got the delete over here, and this is the setting part. This is removal of I, and this is just a delay to make this one work. That's everything for the overwriting of each cell, which is the green wire. And that is one half of the functionality. The other half is the red wire, which also deletes the cell, the current cell. No, it actually deletes all cells above the number 4. And these here are equals, and these two are above. You can see there's a small difference. This one listens to 3 and this one listens to 4. This one over here, this cell is the 3 cell, and this one's the 4 cell. 4 cell gets resetted, while these get activated whenever this one has a signal. Recall, I said cursor position. If cursor position is at 3, that means shifting up everything or shifting down everything above the cursor, including the cursor cell. So if 3 is activated, these fellows here need to work, because 3 commands a shift up or shift down. Either way, all the combinators above 3 need to work for that. We got this half, which is shift down. As you can see, the direction goes to left, and we got this half, which is shift up, which is direction right side. You can see U for up and D for down over here. And we got this one, this inverter for D and U, in case that we want, no, not in case, because we want to remove the control value from the output of the shift combinators. That is their whole purpose. And I think I could not have used 1, because this one transfers everything, and I'm using the C to clear all the digits, because I'm sending a C of value 0. Everything above 0 gets deleted by using this combinator. I cannot use this combinator because this checks for exact match. I want all the cells to be activated when I clear the display, so I have to use this combinator. Means I would also have to filter a C from here, but there is no C if we shift, and that means that we get a minus C here every now and then when we clear the display, and that gets stuck in there. So I put 2 of these here, which just remove whatever is currently incoming. And that is actually the whole functionality of the digits. And it took me some time to design these, and it took me a bunch of iterations. I started with this, which is just a plain shifter. I can just shift up and down with it. So that was basically a proof of concept to just shift up and down. The next step was to actually add the cancellers to this, so that I won't have the data garbage, which I just explained. And I also made the clock for the cursor, which is doing nothing special at the moment. It's just there. I created it at this moment. The next step was to have the whole unit, which actually was functional. And here you can see some manual inputs where I said how much I want to shift. Or no, which position I want to shift, and this is the value which I want to insert. And with this I can insert with the I. Pretty easy to use. And this one was just a copy of that with a different digit and the CU in really inefficient. I had like this bunch of stuff which later became this small part over here. And now we're at this position. We're at this point where we have this compressed CU. I think I explained everything. I wrote a little Java program which helps me to create the char set of the display. I don't have any point where I tested that, but it's really practical because you just select like one display and it will know which pixel has which item and then generate these constant combinators. So all you copy one digit and then you run the program, and the program knows the font, it needs to know the font, and it gives you blueprint for the constant combinators back. So you can just change the items in the display. If you ever intend to write something like that, ask me to provide you that file. There's another neat feature I made for all this. I hope you did not expect me to move the stuff around by hand or like with blueprint. Like if I use this, I can copy that one, but the wires are all disconnected. That is a pain in the butt. Like by now I can just do this one and the wires are moved with it. And that is because I have a special mod which does that. I wrote the mod myself yesterday and today, like yesterday evening, and then I went to bed, and this morning I made the rest of it. And after I finally made a version which halfway works and swearing a lot about the Lua API, and not the Lua, the Factorio API. Naming of that stuff is horrible. I managed to get a version which works, and it's so easy to break this current, like it does not support ghost stuff. If you see this, if I have something which is rotated, it doesn't apply the rotation onto the cursor because it can't. In terms of the cursor of the one which you're holding, there's no Lua method to rotate this. Like if I press R, why is that not a thing? I can, however, do something, well, not this. I can, however, do something like copy this, and you see this is rotated. I could make something like this, but if I place this, it's a ghost. I could, however, recognize that state and then remove it. Also, I think if you're crafting stuff and you're doing this, it holds the item, but as soon as as a new item gets crafted, it will be put into the cursor, I assume. I have not tested that. But whenever that happens, my plugin will think, oh, you changed it, and stop the move operation. I will probably fix one or two things somewhere soon in the plugin, because you don't want to like break the game by putting stuff like rails down and then oops, I just broke the game. Yeah, so there's still a bunch of stuff to fix in this plugin and a whole lot more to improve, but I'm not in the mood to do that because as I said, I was swearing a lot and it's really a pain to write mods in Factorio, but I'm slowly getting used to it. Is there anything else to say for the typewriter? I explained every component of it, or I summed it up. It wasn't real explanation, and I will provide a blueprint, and yeah, I think that's it. And with that, I should quit the video. If you watched the whole thing and you liked what you saw, well, I don't care for thumbs up, but leave a comment, that would be much nicer. What you think of it, if you see improvements, if you think that something is like not well done, not properly done. Oh, by the way, ignore the bugs in this one, it's just because I expanded the CU and thus it fails. This one works properly. Yeah. Have a nice day.